Hello everyone, and welcome to today's webinar, Supporting Safety with ANSP Communications Network Upgrade to IP MPLS. So, before we get started, I'd like to go over a few items so you know how to participate in today's event. You might have joined the presentation listening using your computer's speaker system by default. If you would prefer to join over the telephone, just select phone call in the audio pane and the dial-in information will be displayed. You will also have the opportunity to submit text questions to today's presenters, and you can do that by typing your questions into the questions panel of the control panel. You can send in your questions at any time during the presentation, and we will collect these and address them during the Q&A session at the end of today's presentation. So without further ado, it's my pleasure to introduce you to today's moderator. That's Colleen Harisco, and Colleen is the Operations Programs Manager at CANSO.
Hi, good morning, good afternoon, and we're having a little technical difficulty with the camera issue today, so my apologies. So good morning, good afternoon, good evening, everyone. Thank you for joining our webinar today on communication, navigation, and surveillance. And so, you know, in air traffic, we talk about that a lot, and everything that is needed in order to make the airspace system work as well as it can, and efficiently as it should, and safely as it should. And so I would like to welcome today's presenters for this webinar on supporting safety with ANSP Communications Network Upgrade to IP and MPLS. Our presenters today are Mr. Mervyn Harris. He is the Global Head of Air Traffic Management and Space for Nokia. Mr. Benoit Leridon, the IPR Business Development Director for Nokia. And Mr. Arnaud Collet, Head of Network Services for SkyGuide. Our first presenter is Mr. Mervyn Harris, and he is currently Global Head for Air Traffic Management and Space Business in Nokia, and has over 25 years experience of working in the ATM market with UK NATS and most recently CETA. Mervyn has established himself as a world authority on emerging concepts and services set to transform global ATFM within the communications, navigation, and surveillance environment. Mervyn was a key contributor to the development of the Pan-European Networks Services, PENS, in Europe, and played a vital role in similar projects globally. So without further ado, Mervyn, you have the floor. Thank you.
Thank you very much, Colleen. The next slide, please. Thank you. Before we go into any detail of what we of our solutions, I'd like to give you a quick overview of Nokia itself. The main four focus areas of Nokia's mobile networks: cloud networks, network infrastructure, and Nokia technologies. You know, with mobile networks, our immediate focus will be on increasing research and development for 5G. And building on a significant progress that we have made over a period of time in this area. In network infrastructure, our focus is on building blocks and essential solutions for critical, mission-critical networks such as what you have, and using its technology leadership in network silicon, software, and automation of you know, to drive digitalization. I think that's an area where ANSPs would probably be ending up very soon with the way things are moving. And cloud and network services is another area that Nokia focuses on in creating value for both our service providers, enterprise customers, as demand for critical networks accelerates, leading in the transition cloud native software as a service becomes increasingly important. Nokia technologies, we will continue to monetize this in lots of ways and grow the value of Nokia's intellectual property rights and intellectual and licensing revenues and so on. Thank you. Next slide, please, Rob. Next slide. So I'll talk a little bit about Nokia and aviation now, and I'll focus more on aviation itself. So Nokia in the aviation industry is well established. As you can see, the four areas is airports, ANSP, MRO, and airlines. With the airport side, we predominantly provide wireless communication. It's globally, we are well established. We've got references like Helsinki Airport, Brussels Airport, and so on. With ANSP business, we predominantly provide telecommunication services, networks, that is. And again, we are well established. I think we're around 20% of the market over here. Some of the references we have is IAA, Skyguide, where we have our guest speaker here as well, Avinor and ENAV, and so on. We're also members of CESAR, CANSO, of course, greatly support Nokia in their endeavors. We're members of ATCA, members of Eurocontrol, and I'll talk a little bit more about our membership activities in Eurocontrol and IQ in the coming slides. Next slide, please, Rob. Thank you. So just to prepare ourselves for what Benoit and Arnaud will be talking about, how we do, implementation of solutions that meet safety requirements. Let's look at it from an overview and see where the current situation is. Despite the pandemic, I think air traffic is increasing. I think in the next 10 years or so, by 2035, the number of planes will double, and we need to park them somewhere. I think the number of passengers is increasing as well. The last count before the pandemic was around 3.8 billion around the Asia Pacific region. ANSP communication infrastructure, I'm talking about legacy technology. Their infrastructure is completely based on legacy environment, and as we know, this is becoming obsolete. The strategy is somewhat fragmented in lots of ways, not because of their inefficiencies, but because of the way technology is moving in the future. So therefore, they have to. There's no one vendor that provides everything. It's a continuous sort of iterative process that they need to go through, and that is basically the issues that they have. Next slide, please, Rob. So there is a need for change, in lots of ways. So what are the drivers for these changes? The drivers for these changes are ANSPs have, their main strategic drivers such as resilience, performance, environment, and efficiency. But importantly, there are other main drivers as well for change, supporting legacy systems and applications, especially when migrating to an IP MPLS environment. You'll hear more about this from Benoit's presentation. The new ATC applications that are coming on board, AMHS, for example, require an IP MPLS infrastructure, which unfortunately previously had been run on X25 point-to-point with CEDN. The cost of supporting this legacy environment is high, and therefore increases pressure to migrate to an IP MPLS environment. At the same time, some ANSPs are asked to reduce charges by the airlines, and therefore they sort of look for cost of optimization. Maintaining safety levels is critical. There's an increasing pressure from safety agencies such as ESA to reduce the number of incidents. ANSP sometimes under contract with airlines. I know a few. They have SLA agreements with these airlines, and when there are issues, they are penalized for these, outages. So capacity is clearly an issue for ANSPs, and airlines as well. They would love to have more airplanes put in the sky and more revenue generated. Next slide, please, Rob. So what is Nokia's value proposition in this whole issue? Nokia's value proposition, overall approach to ATM business is a unified approach. very similar to what Cesar does with the Single European Skies. We strongly believe in innovation and strategic partners. Our value to ANSPs is that our solutions are built around their requirements, right? It's built around their requirements. Safety is uttermost important, which translate into stringent availabilities, and we continue to support these ANSPs in meeting safety standards. Obviously, reducing cost is an ever-returning topic for ANSPs, especially as a result of negotiations with airlines. Nokia can help in reducing their cost as well. There are ways, particularly when you put in, single routers rather than multiple routers. So we'll be able to reduce the cost. And a very important aspect of this whole thing is trust. I think, coming from an ANSP environment, trust is very important. There must be evidence in recognizing as a trusted partner is based on, this is based on the references we have. And as I showed in the previous slide, there is tremendous references that we can prove. And we are also continually working with, organizations like CANSO and ATCA and ICAO to ensure we understand your business and requirements. Next slide, please, Rob. So why Nokia? Not only because of our understanding of ATM requirements, our strength in delivering robust solutions, and keen to work with you, not just on a build and operate and transfer, but we can do much more than, help you continually, and our references will vouch for that. But we also, our design should and will meet ATC safety requirements. We are particular about that. We know what most of the requirements that are explained in the next slide, coming slides. We ensure our design provides adequate resilience, whereby continuity of services is not impacted. We are a trusted partner, and our security, we support all traffic types, and topologies. In fact, we provide cybersecurity to a similar mission-critical organization globally, meeting even the ICAO 7 pillars that ICAO has recommended. We ensure compliance to network configuration to a gold standard. Next slide, please. So putting it all together, what we provide, in summary, is an ANSP high-performance network that connects up both not just the ACCs, but also connects up your control towers, airports, and so on, with on any basis, whether it's managed services, but with a high degree of security that provides both reliable, cost-effective, and supporting your legacy environment without, implementing additional routers, and a design that meets safety, a design that meets both safety and security standards. So how do we do that? Next slide, please. So how do we do that? How do we ensure that we continually provide this service? We are, as I said earlier on, members of CANSO, ICAO, Eurocontrol. So we regularly sit on these committees. We work with these working groups, in developing standards, implementation, aligning with and ensuring we align this with the ANSPs. With safety case, as I said, we design the network to meet safety standards. We're continually, meeting EASA as well. We provide continuous reports for safety requirements where necessary with the existing customers. We ensure, and we guarantee that we meet the ED standards that are identified for ED 136, 137, 138. As part of the Eurokai standards. We meet these standards, and we are more than happy to vouch for it and support this. So thank you, Rob. Next slide, please. So I talked a little earlier on with the references. I didn't talk much about the airlines part. The reason being is this couple of slides here will talk a little bit about the airlines and our solution for communication to the cabin. Next slide, please, Rob. So, Nokia has come up with the unique solution where we deployed over 300 radio stations in Europe and provide complete in partnership with Thales, Inmarsat, and T-Mobile, where we provide complete connectivity, Wi-Fi like solution to the cabin, and this has been recognized on a global basis. And as a result, we have been contracted by IAG, the International Airline Group, which is British Airways and Iberia and so on, to provide this service for them in Europe. We're planning to extend this service, but obviously we'll do it on a structured basis. So based on this, next slide, please. So based on this, we also had one research and development project called FACT under CESAR, this Horizon program. And this is in partnership with 6 partners, which includes Honeywell, Eurocontrol, and University of Turkey, and so on. And the objective here is to evaluate 4G, 5G technologies for use at, for air-to-ground communication. This project has been kicked off. It's part of the exploratory program that under the Horizon Single European Skies as our program. It's a 2-year project. It started in July. I think it was delayed a little bit due to COVID, but it's a 2-year program and due to end in 2022. Thank you very much, Rob. Pass it to Arnold.
Thank you, Mervyn, so much. That was really informative. I was especially interested and grateful for you bringing up that, ANSPs, especially during COVID, right, how they are looking at their capital expenditures right now. Are they looking at them differently than they were pre-COVID? Because, the airspace has always remained open, even though there was such less demand in the airspace, but the airspace had to remain open. So it did really impact ANSP income during that time. So I was really grateful that you mentioned that, because I think it's always that balancing act of competing priorities, and then maintaining legacy systems is always when do you get to that point of diminishing returns, right? When is it necessary to really make the switch? So I really enjoyed that. And the other thing that I really loved about your presentation is just the industry collaboration that Nokia has embraced to move this technology forward and globally, to harmonize around the world. I think that that's just really commendable, and I very much appreciate it. So thank you very much.
Thank you. Thank you very much.
But before we move on to our next speaker, I would like to remind everyone, if you have any questions for any of our presenters during this webinar, please put them in the Q&A, and we will be happy to get to those. So our next speaker, Mr. Benoit, I'm sorry, that's the wrong speaker. Our next speaker is Mr. Arnaud Collet. He's the head of network services for SkyGuide. SkyGuide, I'm sorry, so Arnaud is the head of network services in SkyGuide, leading teams of 30+ network engineers and technicians. He is responsible for network services, unit provisions, and operates SkyGuide's connectivity services, both LAN and WAN, and ensures continuous operations and manages services and portfolio evolutions. Arnaud joined SkyGuide on September 1st of 2011, first as a WAN network engineer, into the team in charge of national and international long-range networks. In 2015, he took over the head of network engineering, and finally, in 2018, the role of head of network services. So my apologies for stumbling over that, Arnaud, but you have the floor. Thank you.
Hello, everybody. Thank you very much, Colleen. Hello, everybody, and welcome to this presentation aiming to provide you with an overview of the very last technology we introduced for the WAN networking within SkyGuide. As you can see on the slide, my name is Arnaud Collet. I'm at the head of the network services group. So my group and my team has been quite busy over the latest years to roll out IP MPLS network within our infrastructure environment. Next slide, please, Colin. So in brief, we will go via a short introduction about SkyGuide, giving you an overview of the strategy for the CNS equipment and environment, explain you what has been the path to undertake this network evolution, and finally try to giving you some hints and feedback regarding the move to legacy to IP MPLS technology by SkyGuide. Next slide, please. So SkyGuide is a Swiss ANSP managing the airspace above Switzerland. Before 21, SkyGuide was known under the name of Swiss Control. Our headquarters is in Geneva, in the very southwest of Switzerland, and we employ roughly 1,400 FTE. Amongst us are roughly 800 ADCOs. We have two ACC air control centers, one in Geneva, one in Diebendorf. The particularities of SkyGuide is that we deliver air traffic services for the civil aircraft, but also for the military aircraft, and we operate on 14 locations in Switzerland. Swiss airspace is known as one of the top, busiest and complex airspace in Europe, and the other particularities is that 41% of the airspace we control is delegated by either colleagues from DSNA or by DFS. Next slide, please. So let's go to the CNS strategy. So mostly we still operate a legacy platform for the three pillars of the CNS role: communication, navigation, and surveillance. So let's go to communication. So today, as said, we have a legacy VCS that are very close to life cycles. So they have already colleagues from the communication has already started activities for the replacement of those equipment. So the legacy VCS make mainly use of E1 or EEM connectivity. Here also we talk about legacy interfaces. We have roughly the same setup for the VCS managing the R2 ADCO telephony services, but we aim to make a transformation there as well by moving everything to one IP. So we organize and we successfully perform a trial with R2 over IP with a session border control that were installed just in front of the VCS to make SIP service transportation between SkyGuide and the partner in Italy. For the radios that are deployed in the field, rollout of IP ready radios is completed since 1.5 years now. So all the radios that are in use are still connected via EEM interfaces, but are IP ready, meaning that we will not have to change anything when we will turn to voice over IP services. Tomorrow, definitely IP end-to-end for radio and telephony services for ADCO needs. The target is 2028. Coming to navigation, here again, quite a lot of legacy systems, the VOR DNME that are installed at specific locations that are basically the waypoint for the aircraft to follow the route. Those systems are almost standalone in the field. We have connectivity to those platforms. It is mainly to send a heartbeat and to be sure that the system is up on the other side. Tomorrow, we have some European initiative like the PBN, the performance-based navigation, ones that are triggering evolution to this navigation platform with the new generation DME that will be very soon deployed. They will move from valley to mountainside. That's a particularity of Switzerland also to maximize the coverage. And here we already receive requirement where it is requested to provide a permanent IP connectivity service to those new generation DME as they will be closely supervised and monitored by the navigation team. For the surveillance environment, today since a while, SkyGuide do not operate anymore any primary radar. We just have secondary one for the civil operations. Those radars has only serial interface, but with the move to IP MPLS network, we are making conversion from serial to IP on the radar side directly, and we carry IP radar signal up to the two major ACC in Switzerland. And we are turning toward the MLAT technology, the multilateration technology, where we successfully experiment a trial in the Italian part of Switzerland. Tomorrow, what is foreseen for surveillance, continue and finalize the deployment of the MLAT technology for the ACC of Zurich and the one of Geneva as well. That will trigger the decommissioning of the approach radar used by those two ACC and to extend MLAT to the overall airspace managed by SkyGuide, with the goal of getting rid of any secondary radars we operate. MLAT also offers the opportunity to move to IP multicast traffic for surveillance data. It's exactly the direction we are today taking. Next slide, please, Colin. So network evolution, where do we come from and where we are today? So before 2020, here I'm talking mainly about the WAN network infrastructure and not the LAN one. So the WAN network infrastructure was set up in the following way. We had a SDH network, synchronous digital hierarchy, providing the backbone service between the two ACC of Switzerland, plus connecting the different sites where we have operation in Switzerland as well. So the SDH network was mainly used to provide IP interconnect service for the need of the LAN network, plus was also providing E1 services to connect the PDH nodes. So on top of the SDH network, we were having a PDH network with node deployed in any CNS station to connect CNS services. Thanks to the large panel of interfaces the PDH network was offering, like E1, EM, serial, synchronal, serial, asynchronal, DTU, and so on. It was quite convenient to serve any CNS needs and requirement with this PDH technology because of the legacy system used by the CNS environment. Nevertheless, early 2010 came time to think about making this one platform evolving, because it was reaching simply its end of life and also end of support. That's why we slowly turned in 2012 to IP MPLS network. We turned to IP MPLS network slowly but surely, I will say. Slowly, because the first network we put in operation was the one serving regional airport. So we'll say the small airport with interconnection service from the main Swiss side that are Geneva and Zurich. So we deploy a small IP MPLS network connecting the 11 regional sites to the Geneva and Dubendorf site. This network was designed around SAR 8 nodes installed in a regional airport, plus SR 7705, 7750, sorry, nodes for the core part of the network, core part being located in Geneva and Dubendorf. Several goals with this first IP MPLS network. The first one was to validate in live, I will say, the results we got in lab. Because obviously we make a full testing and full check of the capacity of the IP MPLS SAR and SR box to carry services like CNS1. So the first goal was to validate with live traffic the capacity of the IP MPLS technology to handle ATC service according expectation and requirements. The second objective was to onboard our ATCO colleague by delivering a running platform where they can make their own experience of using this kind of transportation of CNS services. Goal here was to onboard them and to give them chance to experience this new way of transporting CNS services. Objective was here, the goal was clearly to address any reluctance we could have from our colleagues, from our ADCO colleagues, to address them, to fine-tune the network so that they got satisfied for at the end to get full acceptance of ADCO with the IP MPLS technology. This point was very important and must not be underestimated because they are the main user at the end of this kind of network, and it's very important to get sponsoring of ADCO for the next deployment. And the third objective of this first regional network, I will say, is also related to the technical department, where they also have to get trained on experience about IP MPLS technology, how to operate such kind of network, to learn how IP MPLS behaves in a live condition, and where to focus on to ensure high availability services. So the regional airport has been running from 2012 until today, still running. But in 2018, thanks to the very nice experience we have with this first network, we start to make the same exercise with the national network. We change a little bit the design of this national network by not making use of the SR7750 nodes that are used in the core part of the network of the regional airport. But for the national needs, we rely only on the SAR8 nodes, also in the core part of the network. So the national network is made of 84 nodes, SAR81, deployed everywhere in the field, plus on the location where SkyGuide operates. And today transport a bit more than 1,000 of CNS services that are on the path to be migrated, to be fully migrated from PDH to IP MPLS. It still remain hundreds of services to be migrated, and that will be made before the end of the year. SkyGuide also operates international networks that connect SkyGuide to DFS, to DSNA, and to ENAV for the need of exchange of CNS services. So before the end of the national network full rollout, we decided to make exactly the same change for the international networks that was based also on PDH technology, with the deployment of several SAR8 nodes to interconnect SkyGuide on DFS. Almost 30 nodes for the DFS SkyGuide DSNA network, transporting 60 plus services, and we are finalizing today the migration of services from PDH to IP MPLS network with colleagues from ENAV, where we set up a network of 5 SAR8 nodes that will transport at the end 22 services. Next slide, Colin, please. So an interesting exercise for the pros and cons between PDH and IP MPLS technology. The main advantage of the PDH one is the predictive routing. It's a kind of network that you can very quickly control any route or service will be taking. With PDH is based on E1 technology, so you allocate bandwidth via time slot to given service. So there is no risk of congestion. Once you have allocated 31 time slot, you consume the overall bandwidth that is given by a 2 megabyte line. So either you manage to get additional E1 services, or you stop adding service on the PDH node. It's also the diversity of interface. We already tackled this point in the previous slide, where almost all were available with the PDH node we were using. And one of the big advantages also is that over 15 years of operation, we had to update 2 times the PDH environment. So it was very stable and was quite autonomous. The constraints, obviously now it's a bandwidth, because the capacity of 2 megabytes is very quickly consumed, especially for IP services. Clearly not IP ready, very complicated to make IP transportation over a PDH environment. And also the rack space consumption, PDH node is minimum 11U, consuming 11U in a single rack, so it's quite big at the end. IP MPLS, one box fits all core and access. It's the experience we have and the successful experience we have with the national network, where we only use SAR8 nodes. So we have a single node that is capable to fulfill any needs. Could be the core, the access, or the transport. IP MPLS handle very well legacy and IP services. It's absolutely possible to make a mix of everything. It's exactly what we were looking for by moving toward IP MPLS. Simple to smart QoS settings to avoid congestion over the network. It's absolutely mandatory to set up QoS. The tool that come with the IP MPLS node is quite simple to manage and to configure, and let the user the freedom to make very simple configuration to the most sophisticated one. IP MPLS also ensure end-to-end full service separation via the tunneling features that is provided. Also improve the security with the possibility to encrypt the traffic over the network. And it's also reliable and mature technology because it's in use since more than 15 years now. Some constraints that has been introduced with the IP MPLS as well is the regular need of upgrading the release version and the NFMP, the monitoring console, and also requires MTU above 20,080 or 2080 if we use the encryption features. Next slide, please, Colin. Hints and feedback. So today, Sky operates 3 IP MPLS network that are today in operation. The Swiss national, the international, the 3 international network is seen as a single network, plus the regional one. All are dual core network. This mainly to mitigate routing errors that could happen inside a core of a network. IP MPLS allows perfect cohabitation of legacy services like serial, EM, E1, G703, and so on, and IP services. And IP MPLS is also a trigger for network conversions to single platform, not only for the one need where we get rid of 2 network, to SDH and PDH network by moving toward IP MPLS, but IP MPLS is also very close to the LAN environment that we operate on our premises. So it helps also to ensure convergence of teams and not having any more people specialized in one technology and others specialized in the LAN technology. Do not forget that when we are carrying a CNS traffic, we need to have ADCEP person managing networks, and IP MPLS is also key to push convergence of LAN and one technology over a single unit. A small feedback for the migration of the radio service. Prefer migration of full radio chain for some sites. For example, in Geneva and Zurich, it's the same setup. We have 2 radio chains. When you migrate one radio chain over IP MPLS, you still have the VCS that is selecting the based on several criteria the best chain, so that when you have one running on IP MPLS and the other one still running on PDH, it's quite not nice for the ad code that the VCS is switching all the time between chain, because the sound quality is not exactly the same, so they perceive this difference. So it's better to not last too long between migration of the overall radio chain. At the very end, when we got very experienced with radio site migration, we had been capable in a single night to migrate 6 radio sites in same time. The most used service, the IP MPLS services in Sky, are the pseudo wire one for the tunneling for E1 voice and Ethernet services, and the VPLS Ethernet. VPLS is a virtual private LAN service, the kind of switches that you can extend through the IP MPLS network. Services that are planned, that has been tested, and that are planned to be introduced very soon is the VPR on IP, virtual private router network. It's more or less the same than the VPLS, but at the layer 3 level. Quality of service, as said previously, is mandatory to limit or to avoid congestion of traffic, because IP MPLS platform of SkyGuide is transport LAN admin services in the same tune that the time critical services. So obviously the time critical has to get the highest priority and not being impacted by a download activity made on the LAN admin network. As said previously, QoS is very convenient to configure, offering capability to configure the most simple stuff to the most sophisticated one. For the network synchronization, it's still required for pseudo-wire E1 services. So two ways of making this synchronization, either sync Ethernet or PTP. But PTP is more complicated to put in place, but it's needed when the Ethernet transport layer continuity is not achieved, meaning when you have breakdown, you are switching from one transportation layer to another one, then the sync E is not usable anymore. You need to go to PTP. We are basically at the very end of my presentation. Colleen.
Thank you so much, Arnaud. I admit that I come to this CNS discussion with an air traffic controller background, and I am even more grateful to you guys that ensure that I can talk to an airplane when I can talk to an airplane, or I can talk to a facility when I can talk to a facility, and everything else that is involved in that. So thank you so much for everything that you do. Your presentation has certainly generated some questions. So we'll get back with you in a little bit. So thank you so much.
You're welcome.
Our next speaker is Mr. Benoit Lerdon. He is a regional IPR business development director at Nokia, responsible for transport, energy, and public sector in Europe. In his role, he is deeply involved in customer projects in the pre-sales phase to understand customer applications and requirements in order to define the proper solution for the evolution of their network infrastructures towards IP. Benoit has 30 years of telecom pre-sales background covering enterprise and carrier markets for data and voice solutions, and has joined Alcatel-Lucent in 2010 after holding different pre-sales management positions in companies such as Wellfleet, Bay Networks, and Nortel. So welcome, Benoit, and the floor is yours.
Thank you, Colleen. Thank you very much, Arnaud, as well. You've given us a very detailed look at how and why you implemented such a technology. I'm going to go through our vision, which is, of course, very aligned with the SkyGuide presentation previously. If you can move to next slide, please. So what we are looking after in ANSP telecom market, on the left-hand side, of course, as I mentioned previously as well by Mervyn, is about safety. So everything around availability, life cycles, cybersecurity are critical, but they are not only critical to the applications, but also to the networks or vice versa. So meaning that, and we will see that after, availability is the key pillar of how we build networks, but life cycles also are critical, and how you move applications, how we ensure that the life cycles of application are fully respected is a key asset, of course. Then on the flexibility, as presented by Arnaud, they are very different applications. So from very low bandwidth, so typically the TDM voice traffic, which is 64 kilobits per second, up to some very high bandwidth, like a couple of megs, and sometimes 4-5 transfers, sometimes some gigabit per second. We've got, of course, legacy TDM, but IPv4, IPv6, IP being multicast or unicast. We use different underlay technologies, being fiber, being microwave, being sometimes even LTE. We see organizations, of course, mainly using private cloud, but some for the critical applications, but sometimes also using the public cloud. And the flexibility is, of course, a key driver for the network itself. And last but not least, the control. The ANSP networking teams are having sometimes difficulties to manage a 24/7, and they need to fully align with the people in operations of the applications by creating the environment that will give these people focusing on applications the correct view on the network, so not detailed, that will help them to easily troubleshoot or answer questions and then poll the experts for the network if need be. So it's ease of decision, ease of troubleshooting. More and more we need to anticipate issues. I'll highlight this. And we also need to be adding value to the DevOps model, where you develop applications, testing in the lab, and how we move that to the live network. So if you move to the next slide, please. So as mentioned by Arnaud, we are leveraging IP MPLS as a technology because it's fully matured and it answers most of the criteria that are in the previous slide. So it's topology agnostic, so whatever rings or point-to-point or full mesh network, we will be able to cope with that. It's very predictable. On the second part, we've got the resiliency. So we don't only bring network resiliency, we go further, we go in on the application resiliency, which is somehow different from SDH, where you have mainly a core resiliency, but not an access. So we do end-to-end collaboration with the LAN. We integrate legacy, so that's basically what Arnaud alluded to on the voice part. Low latency is at the core of what we need to do, and I will show that next. So fully helped, of course, by the quality of service. Clocking, so synchronization is a very boring topic, of course, but very important to ensure that all applications are maintained fully aligned from a synchronization perspective. We then integrate all applications on this IP network, regardless of how they are built. We adapt the network to the applications. We don't need to do vice versa. That's also a very key message. We're building a first level of security, and of course, something to highlight, which is the ease of management. MPLS is also on the right-hand side capable of massive scales. Of course, we've got network with more than 10,000 units, which is more than any NSP probably will have to cope with. And it's very future-proof. So there are evolutions to this technology that is bringing value, simplifying or providing new services nearly every year. But you don't need to upgrade every year. I will highlight this as well. If you move to next slide. So this is a typical design of NSP networks today, with typically two telcos, the blue one and the red one. Those two being, of course, either service provider, then it's a real telco, so providing point-to-point service, but it could be also resources from the NSP itself, like dark fiber or microwave sometimes. So dual telco, of course, minimizes the dependency and the common mode of common failure scenarios. So that's very important in terms of availability. With MPLS, we can also redirect the traffic to the blue and the red. We force the traffic in a direction, which is something that IP alone cannot provide. So it's, from that standpoint, very helpful to provide full availability of the application. From the benefit, of course, to end-to-end resiliency, because as you can see on the bottom side, you've got two red and blue applications, so typically two blue and red servers. On the left-hand side, upper, you've got an application, and I've put a radar here, but it could be any application that has two interfaces, let's call it a blue and a red, and you would ensure that they both don't share any shared resource. Or if you don't have an application that is capable of providing resiliency, on the right-hand side, you see that you can duplicate the application and fully leverage the network itself. So that's really an end-to-end service availability to the application. Next slide, please. As mentioned, QoS is at the core of these networks and can be very precise. I mean, honestly speaking, I think I've never seen so deep discussions on QoS than the ones we can have had with SkyGuide. We even enhanced the products to fulfill the needs. What we provide in the notes is what we call hierarchical QoS. So if you look at the right-hand side of the drawing, you see the mission-critical backbone where you have different VPNs, so different conducts for the different applications. Then we've got the gigabit Ethernet or microwave interface connecting to the network on a specific site. With the segregation, the first level of segregation, I'm moving left, where you have the radar VPN at the bottom. You've got the IoT VPN just above in blue, and then the IT VPN on the top. So that's the first level of segregation in the hierarchy of the QoS, because here we protect the application so that nobody can eat the bandwidth of the radar system. This is reserved 1 megabit per second or 1 gigabit. Sorry, I can't see, it's too small. But then on the left-hand side, you see also that each application has its specific behaviors and requirements in terms of QoS. So for example, for the weather sensor data and weather sensor control, you may use different QoS patterns here. So with the hierarchical QoS, we not only ensure the delivery of the applications, but also we ensure that each one has a respected bandwidth allocated to it. So so with that, we've got multiple options of ingress, egress QoS that can lead to what is expected by the application. QoS is one thing from a software perspective, but it has to be driven by a hardware that is fully capable of managing such precise kind of microseconds behavior. And this is something that at Nokia we do very well. We developed our chipset since 18 years now on the 7750. And this gives a lot of granularity where most of the systems that are trying to compete with ours are built on silicon from the market, which are basically for Ethernet switches in the enterprise. So completely different behavior. So we continue to trust in the fact that a dedicated hardware silicon in the node is much better to fulfill the requirements of the QoS in particular. Last but not least, we contribute, of course, to the ED standard. So all the standards being here 136 to 139 to ensure proper latency, jitter, and control of the application of the network to serve the voice applications. If you move to next slide, please. You could click again once, please. There is an increasing pressure of safety and forcing the networks to behave correctly under any cybersecurity attacks. So from that standpoint, we start by having a very solid, secure foundation in the software of our routers. This is our SROS, so it's the software that runs on the different products that we are selling in this market, and we are very proud to say that within more than 18 years of operations, and we've sold 1,003,000 units, we've never had to develop a patch for an emergency case, meaning that we find the software issues in the lab more than in the field. That is absolutely critical. Of course, we need a secure management, and then if I turn clockwise, one of the big value of MPLS is to bring segmentation and even what we call now micro segmentation, which is within, instead of putting all an application into a VPN, we start segregating the application in different VPNs to ensure even better security. We have, because of MPLS, a need to protect the nodes against attacks, because MPLS was provided to fulfill the needs of operators that are sharing the infrastructure. So we've got the protection against DDoS attack. Again, moving clockwise, we can encrypt at different layer, being physical with microwave, with MACsec. We can manage with IPsec as well, mainly for interoperability. But we otherwise prefer to use what we call NGE, which is encryption at the VPN layer, which brings much more flexibility than IPsec. Then we start moving into the application protection itself, where we provide in the nodes the capability to install a lot of filters to protect the applications and even firewalls. And of course, all that has to be consolidated into a reporting tool. So if you move to next slide, you see that time is running. This is a typical network where, again, we have all these applications being transported over a single network with custom QoS, and each VPN has limited resources in the nodes so that any failure or degraded scenario can be fully anticipated. Yeah, if you can move to the next slide. So this is a typical example of what we do and what we have learned in our projects around Europe. The different, you see on the left-hand side, the applications. In the middle, there's some details about the application, some kind of priority. Of course, we can argue that all these ones should be priority one. The kind of interfaces, and on the right-hand side, the type of resources or recommended VPN technologies that are to be used, whether there are TDM pseudo wires for voice, multicast VPNs, unicast to multicast translation, NAT, VPLS, VPRN, etc. And of course, we've got new technologies coming in here with EVPNs, for example, that are the next generation. No need to migrate now, but we're starting to see customers using that from a greenfield perspective. If you move to the next slide, please. This is the typical node that we provide that made the success of Nokia in the critical networks, but also the successful transformation of many ANSPs. It's an IP MPLS node that is capable of transporting any application being IP, as you can see on the right-hand side, so Ethernet, typically for CCTV, PC, whatever. And then in the dark blue, you can see all the direct connections that we have inside the node to provide serial connections, ENM for voice, FXO, FXS as well, some dry contacts alarms, E1s, a GPS clock, and all that being safely transported over IP MPLS, sorry, using either gigabit Ethernet, sometimes still SDH or microwave. Maybe you can move to the next slide, please. I just wanted to highlight a couple of comments on the network management system. So network management system is more and more called an orchestration tool because it has to fulfill more needs than just monitoring. So at the bottom, we've got the applications on the drawing. Then we've got some network routers. So again, it might be a blue or red. Sometimes in some environments, you see more. And then these nodes now have new protocols. Of course, the, let's say, legacy protocols that are going to be used still for years, as SNMP or SSH can still be used. But we have means like telemetry, which is more capable of transmitting information than SNMP, NetConfiang, which is supposed to be more open tool. And then if you go north, you see the programming interfaces, which can be GMS or XML, but could also now we use more Kafka or gRPC. So all the management system is more and more open from a northbound perspective, allowing more integration into any OSS tool. We can also manage different layers within Nokia, so the WDM, the microwave, and the IP layers, which provide easier operations. And more we can do anticipated reaction, like kind of what if scenario, dynamic adaptation of the network, etc. So if you move to the next slide, please. This is typically a console here for monitoring the network that we provide to ANSPs, where you see two types of monitoring. The first one, like folders where all are red, it's not a live case, it was in a lab, where you see the different applications, so that in the control center, people can have a look that if there is a problem on VCS and the VCS folder is red, it's more probably a problem of the network rather than a problem of the application. If the network would have been green and the VCS had the problem, more probably you need to focus on the application. So that's one view. Then on the bottom where all the icons are green, you see the different segments, what I call the segments here is the different telcos in the drawing where we had telco 1 and telco 2. And so you can easily view that if there is a problem on the managed network itself, so the routers, or if it's on the transport from the carrier. And last but not least, of course, a traditional view on the physical layout, as you can see on the drawing as well. If you move to next slide, will be my last one, I think. What is more and more appreciated by ANSPs is the capability to measure SLAs. So measure SLAs on the right-hand side with the green arrow is how we control that the SLAs provided by the telco, the operator, are fully respected. And on the left-hand side is the SLA for the application, where you as an NSP can go to your respective application management and say, okay, I mean, the network is behaving normally, or the network is having delays. So you can easily troubleshoot with these tools. Those tools can be launched permanently, and therefore you can provide this kind of graphs on the performance of the network, or they can be launched on demand by the tool, by a couple of clicks, even though the mechanics behind are very complex. the tool will provide very graphical means to launch these probes. If you move to the next slide. So that would be the conclusion. Again, I very rapidly highlighted some of the key benefits of the IP MPLS transformation tools from Nokia, providing very highly robust networks from a design perspective, but from a product perspective as well, operating system and hardware. All applications are securely integrated, so we don't force a life cycle of application to, for example, move all to IP. They are all integrated and all optimized. And then the last one is control operation. The network technology allows to have very controlled operations, but also the network management tool provides this capability as well. Then that concludes my presentation. Thanks, Colleen, and I hand it over to you if we still have time for questions.
Thank you, Benoit. Yes, we are actually at the top of the hour. However, if everyone that's on the call could indulge us for another 10 or 15 minutes or so, we did have some really good questions come in through the audience. So I would like to beg your indulgence for another few minutes to answer a couple of them. So Christian, if you can bring Arnaud and Mervyn back up, thank you. So this question is for Arnaud, and it says, can you comment on the choice between using VPLS and VPRN? When would you use VPLS instead of VPRN?
Quite difficult to answer the question because as today we are not using any VPRN service. I said that we plan to make some trial, and it could be that we introduce it, but we are not using it today. We use only VPLS service, and VPLS is the capacity to extend via IP MPLS a private network up to the final point, remote location, for example. This private network is making use of IP addresses that are completely separated by the one the IP MPLS network use itself to route traffic from one node to another one.
Thank you. Does anyone else have a that was specifically for our node? I don't know, Benoit, if you have any thoughts on that?
No, I think given the same answer, so no, it's okay with me.
Okay, great. Well, thank you, Arnaud, and thank you for the question, Hansen. So the next question is going to be for both Arnaud and Benoit. First, thank you for sharing your MPLS experience, especially with ANSPs. What are your own operational experiences when considering SD-WAN versus MPLS, which are considered more secure and flexible? Let's start with Benoit.
So, yeah, that's a very interesting question because we get it regularly. So I think first of all, you need to look when you hear about the technology, you need to get where this technology, what was the technology built for? And SD-WAN was mainly built to run traffic over internet and have a very centralized operation. So in the case of ANSP, of course, you don't run your applications on top of internet. So there is, for me, a kind of disconnect here. Then, so that's the first thing, and it's very important as well because it drives a lot of issues on SD-WAN. Again, in this context, it has its values elsewhere, but the type of devices that you use are x86, and for example, for QoS, these are not done to provide very deep QoS. So I think the second part I wanted to mention is that, again, yeah, it lacks a lot of very important support for some of the applications that were mentioned previously. So typically TDM, it has no deep QoS, as I previously mentioned. High availability, we measure that when we talk to ANSPs in milliseconds. With SD-WAN, we're talking here about seconds or tens of seconds. And then multicast, for example, which are used in radar applications, for example, more and more. Multicasts can't be transported over SD-WAN. So all this means that, yes, very sexy technology, may be helpful for the IT department of an ANSP, but again, what is done for me by SD-WAN, everything can be done by MPLS forget about internet because I think it's not relevant here. So yeah, that's our position on SD-WAN, not applicable for the most critical networks.
Thank you, Benoit. Arnaud, do you have anything that you would add to that?
No, I guess Benoit covered the point, but on an operational point of view, I will say, when we are rolling out technology and when we are making a migration like the one we made from PDH to IP MPLS, the goal at the end is to have something that is capable to support operational traffic. We try as much to not mix up too much several technologies. So the goal was there to go strictly toward IP MPLS, to have a stable and running platform. And it could be that in the next step, if it's relevant to have this SD-WAN technology introduced, we go toward an hybrid setup. But as said by Benoit, SD-WAN has been more designed to manage backbone traffic, I will say. Here we have a setup with the IP MPLS setup that is not managing any backbone interconnect services. This part is dedicated to the DVDM platform we have in operation between Geneva and Zurich. For this operational network, we don't care at all about any kind of internet traffic because simply we are not using internet to carry any CNS services.
Yeah,
Okay,
so maybe just, sorry, I'll add one comment.
Sure.
SD-WAN is again a technology to connect branch offices mainly, and what we see, and I've put that in one of the slides, is what we call carrier SDN, where we bring some of the value of SDN, software-defined network, so the platform can drive some specific scenarios, automate some features, some deliveries of services, some programming, etc. Again, ANSP networks are probably not the first one to be moving in that direction because of the sensitivity, and they are kind of also more or less static networks. Yeah.
Okay, thank you, gentlemen, and thank you, Michael, for the question. A question that came in early, Arnaud, when you were speaking, was the Swiss MLAT is a LAM at the moment, also serial data output, not IP. I'm hoping that that makes sense to you. Again, air traffic controller background.
I'm not sure to fully understand the question, but our MLAT network is based on sub-Sensis remote unit sensors that are deployed in the field. And the sub-Sensis sensor has IP interfaces for the throughput. So they are connected via Ethernet line, and we collect all the traffic of the connectivity coming from those sensors in Dubendorf directly. So all those sensors are connected via telco services, telco Ethernet services released to this telco directly. So we don't have any serial data output for the sensor we are using for MLAT.
Okay, thank you. Thank you. That cleared it up for me. So I appreciate that.
It would have definitely been a pity to have MLAT sensors with serial interfaces where we're heading to have only IP CNS equipment at the end.
Sure.
Thank you. Okay, I think we'll entertain two more questions and then we'll wrap up. Does Nokia support the development of ANSP safety cases in any new implementation? And this might be for either Mervyn or Benoit, I would guess.
Mervyn?
Yeah, I'll take that question. Thanks, Colleen. Yes, I'll take the question. Yes, we do support. I mean, our whole ethos and the approach we take is to ensure that ANSPs meet their safety requirements and safety standards, even if it means that we either directly or indirectly engage with safety consultants from outside the ANSP and from the industry itself. So we bring in these people and we do a lot of analysis internally that supports ANSP for their data when they do the safety cases, particularly on RAM analysis and so on, that we do a lot to provide that sort of support to the ANSPs.
Thank you so much. And I think our final question today, how does Nokia manage migrations in the context of ANSP applications? This might be for Mervyn again.
Do you want me to take that one?
Yeah, okay.
Or Benoit.
That'll be good.
I don't know, as you like, but okay, so I'll take it. So this is a quite complex questions, and I'll try to simplify it. So what we as Nokia do is provide network migration. So in that sense, the nirvana would be that you have the current network today, and we as Nokia are having a new contract, and we deploy a second network, and then you pull your application from network A and connect it to network B. Then in that case, that's the nirvana. But in reality, this is never happening like this, because you may have, you need to have more interoperability between the networks to have a smooth migration. So it's a little bit more complex. We don't do we do network migration, so we interoperate the two, we provide some guidance, etc., but we don't do application migration. So this is in the hands of specialists. We are not certified for radars or VCS systems. So we help, of course, because we know the network, so we would provide the right tools to ensure that the application migration is smooth. But this is not our mandate. So we rely on partners or the ANSP itself. I think in the case of SkyGuide did manage the migration of the applications on their own.
Okay, thank you, Benoit. And I'm sorry, go ahead.
No, you're welcome, I said.
Oh, apologies, I stepped on you. So I would really like to thank Mervyn, Arnaud, Benoit. Thank you so much. I, for one, have come away much smarter in the world of CNS, and so I very much appreciate your contributions, those of Nokia. And again, just really love the idea and impressed and awed, and I think it's just so neat that the industry collaboration that you have designed in this whole area is just really impressive, and I'm really grateful for that. So thank you. So that's really all the time we have. Again, thank you for your time. For those of you that have joined us in the webinar, thank you for the privilege of your time. It's been really kind of a informative and enlightening hour and 10 minutes. So I very much appreciate it. So that, I guess, would conclude our webinar, and I will hand it back to Rob. Thank you.
Thank you, Colleen. And thank you everyone for joining us this afternoon. Once you leave today's webinar, you are going to receive a survey, and we would very much appreciate it if you could complete that and provide your feedback. So once again, on behalf of CANSO, Nokia and SkyGuide, thank you everyone for joining us today, and enjoy the rest of your day.